What's up, everyone, and welcome back. Patrick here, moving on to another question dealing with graphing factored form quadratics. So we already went through a couple of videos dealing with this. Hopefully you're watching this on the website and following in order, because the process that I went through in the previous videos, I'm going to be going through in this video as well. If you're watching this on YouTube, you can go to the description box and there will be a link to the website where you can watch these videos in order. So same process is going to apply, but notice that these here, they look a little bit different. These two, notice that it's not just x minus something or x plus a number, there's the coefficient in front now. So it's going to change things a little bit when we're finding the x-intercepts, not too much though. The x-intercepts are actually going to end up being fractions, so there's going to be a little bit more algebra in this video versus the other one, but the general process of finding the x-intercepts and finding the axis, finding the vertex, etc., is going to remain the same. And then here, part C, these here are actually in that same format where the x is by itself. There's no coefficient in front, like in A and B, but notice that these values here are fractions. So again, the algebra is going to be a little bit more complex, but the same process is going to apply. So let's start off with part A. We got y equals 2x minus 3 times 4x plus 5. So the first thing is let's find what the x-intercepts are going to be. And how we do that is algebraically, we let y equal 0. So we plug in 0 for y, and then we have to solve for the x values that are going to give us a y value of 0. So if you remember before, what was happening is we had quadratics like x minus 2 times x plus 5, for example. And then we could see from here, whether we did it algebraically like this, but even just looking at it, we could tell that the x-intercepts were 2 and -5, for example. However, unfortunately here, you can't do that. So for example, in this bracket, the x-intercept is not going to be 3. Okay, because if you notice, if we plug in 3 over here, we wouldn't get 0 in this bracket. We'd get 2 times 3, which is 6, minus 3 would give us 3. Versus here, if we plug in 2, we get 0. Here, if we plug in -5, we get 0 as well. So what we have to do here is we have to actually algebraically figure out when is this bracket going to equal 0, when is this bracket going to equal 0. And so notice there's going to be a little bit more work here to isolate for the x. It's not going to be too bad because all we have to do, bring the -3 over, and then divide both sides by 2, and so we end up with 3 over 2. So that there would be the x-intercept, 3 over 2, and then the other x-intercept would be 4x equals -5 when we bring it over, and then x is -5 over 4. I'm going to keep these in fractions. You can use decimals as well if you want, so this would be 1.5, this would be -1.25. Okay, but just in case your teacher requires you to work with fractions, that's what I will work with. So those are the x-intercepts. And notice if we take 3 over 2 or 1.5, plug it in here, 2 times 3 over 2 or 2 times 1.5 gives us 3. Minus 3 would give us 0 in that bracket. And then 0, if we plug in 1.5 here, it's going to be some kind of number. I think it will be actually 11. So we'll have 0 times 11, which would give us 0. Right? So you can double check these answers by plugging them back into the brackets and just making sure that you get 0 for each respective bracket. So in this case, the x-intercepts are 3 over 2 and -5 over 4, or 1.5 and -1.25. Okay, so we have the x-intercepts, they're fractions, but same thing applies if we want to find the axis of symmetry. What do? We add the x-intercepts. So it'll be 3 over 2 plus -5 over 4. And then we just divide by 2, like that. So again, a little bit more algebra, but the overall process is the same. So 3 over 2, we can get a common denominator here. We'll multiply this by 2, multiply this by 2, so we'd end up with 6 over 4 plus minus ends up being minus 5 over 4, and then we're dividing by 2, so we'd end up with 1 over 4 divided by 2. That's like dividing by 2 over 1, so we could rewrite this as 1 over 4 divided by 2 over 1, which equals 1 over 4 times 1 over 2. If we flip that second fraction, so we'd end up with 1 over 8 for the axis of symmetry. So the vertex here, we're going to end up with 1 over 8 for the x value. And then if we want the corresponding y value, we would just plug that 1 over 8 into the function. Now, another thing that you can do is this 1 over 8, let's actually keep track of the decimals. So the x-intercepts, I actually recommend keeping track of the decimals because it's then a little bit quicker and easier to check your answer. So what we can do is, notice if we do convert everything to decimals, 1 over 8, that ends up being what, 0.125. And so you could check quickly with decimals, are we getting that? So if we take 1.5 plus negative 1.25, that'd be like 1.5 minus 1.25, which would give us 0.25. Then when we divide by 2, we end up with that 0.125 right there. So you can have the decimals on the side to check your answers, or if your teacher allows you to work with decimals, that could be your main work as well. But in case they want the fractions, I'll keep the fractions as well, or I'll show you how to do the work with the fractions. So to get the corresponding y value of the vertex, we would have to plug in that 1 over 8 for the x, right? So as I mentioned, just a little bit more algebra here, but it's not too big of a deal. We've done a lot of work in this course so far with fractions, so you should be fairly comfortable doing this stuff by now. So 2 times 1 over 8 would be like 2 over 8, so that would be 1 over 4 minus, this is like over 1. So multiply this by 4, multiply this by 4 would be 12 over 4, like that. And then 4 over 8 would give us 1 over 2 plus 5 over 1, multiply this by 2, multiply that by 2, so it'd be like 10 over 2, like that. Give me a sec. Yeah. By the way, I'm kind of skipping a lot of steps here, so if you want to take a few more lines to get to these parts, feel free to do so. Just make sure that you're getting, whichever way you're doing it, make sure you're getting the same values that I'm getting here. Now, 1 minus 12 would give us negative 11. That's going to be over 4. And then 1 plus 10 would give us 11. That's going to be over 2, like that. And then from here, we're multiplying fractions now, so all we have to do is multiply the numerators, which would be negative 121, and then multiply the denominators, which would be 8. Right, so negative 121 over 8 ends up being the y value of the vertex. Now, as I mentioned here, I would recommend keeping track of the decimals here, not only to check your work on the way, but also it's going to be a little bit easier to graph, I feel like. So negative 121 over 8, if you plug that into your calculator, that would give you negative 15.125. Like this. I mentioned in previous videos, whenever we got fractions here, sometimes it's good to get the decimal because it's tough to see what number this is going to be over here. So it could be tough to know where to put it on the graph, but if you have the decimal, it's easier to see where it goes on the graph. And then you could also check your answer, so you could plug in this decimal here and here, multiply those two, and you should get that value right here. Just watch out with your brackets and your BEDMAS when you're doing that. And then also what I'll do is I'll actually find the Y-intercept as well, because it's fairly easy to do so. We just have to plug in an x value of 0. So we'll plug in 0 here, plug in 0 here. Notice that this would go to 0, this would go to 0. We'd end up with negative 3 times 5, which would give us negative 15, right? So it's just a point that's quick and easy to get, even though they're not asking for that point. And then it also, as I mentioned in the previous videos, it gives us more confidence when we make the graph and everything makes sense once we add that point with these characteristics over here. So let's draw the graph over here. And the x values, you can go up by whatever scale you want. You can go up by ones maybe. The problem is if you go up by ones, you'll have like 1, 2 over here. Notice that we're not dealing with very big x values for the x-intercepts. So it's going to be a very small graph. So if you want to zoom in a little bit more, you can use whatever scales you want here. But what I'm going to use, I'll go up by 0.5. So we'll go 0.5, we'll go 1, and then we'll go 1.5 over here. And then same thing, we got to keep the scales constant. Like that. And then the y values, let's go up by 3. So we'll have negative 3, negative 6, negative 9, negative 12, negative 15, negative 18. So I'm just going to label the negative 15, negative 18. Actually, you know what? Let's just label everything. Why not? So like that. And then the y values, I don't think we're dealing with any positive y values, but let's just put 2 there, 3, and then 6, like that. Right, and I feel like those are good scales to plot all of these points here. So again, when plotting, maybe you want to label with the fractions. Maybe your teacher will require that, but plotting it, it may be better to do with decimals. So the two x-intercepts are 1.5, negative 1.25, so we'll have 1.5, which is over here, and then negative 1.25, which is in between negative 1 and negative 1.5, so that's going to be like over here. So this is going to be 3 over 2 and 0. That's where the point's going to be, and then over here this is going to be negative 5 over 4 and 0, like that. We also have the y-intercept at 0, negative 15, and then we have the vertex at 0.125, which is going to be like over here, let's say, a negative 15.125. So that's going to be like right there, approximately. And so notice it's making sense when we join everything up. We'd end up getting that, then the vertex is here, then it's going to come back up, go through that y-intercept of negative 15, and then it's got to go through that other x-intercept of negative 5 over 4 and 0, or negative 1.25 and 0. Right, so that's how this graph would look. So again, exact same process, it's just a little bit more algebra when you're dealing with these fractions, and I'm actually going to label the vertex. Forgot to do that. Over here, like that. Right, so just a little bit more work with the fractions. Now moving on to part B, we got y equals negative 2 times 5x plus 2 times 3x minus 8. So notice that these factors here, they're in the same format as part A. It's just we have this a value now of negative 2 that we'll have to incorporate into the calculations, but that's not going to be too big of a deal. So for the x-intercepts, same thing. Let's figure out what x values would give us a y value of 0. And then we'll write everything out. Now, as we showed in previous videos, this a value doesn't affect the x-intercepts, right? We're still going to find out when is this bracket going to equal 0, when is this bracket going to equal 0 for what x values. Well, here we'll have 5x equals negative 2, x equals negative 2 over 5. So that's going to be one of the x-intercepts, and then over here we'll have 3x is equal to 8, x equals 8 over 3. That's going to be the other x-intercept. And again, if you want to check these values, plug it in here, plug 8 over 3 in here, you'll get 0. Plug negative 2 over 5 here, you'll also get 0 for the bracket, which would make the whole thing 0. So let's keep track of these x-intercepts over here. So let's write out the full coordinates. So we'll have negative 2 over 5 and 0. That's going to be one of the x-intercepts, and then the other x-intercept is going to be 8 over 3 and 0. Now let's also keep track of the decimals. So the decimal values of this, negative 2 over 5, that would be negative 0.4 and 0. And then 8 over 3, that's 2.66 repeating. So I'll just say let's actually just round to one decimal place. So we'll have 2.7 and 0. You could round to 2 decimal places as well if you want. So it would be 2.67 then. I'll just round to one decimal place. So those are the x-intercepts. Now, if we want to find the axis of symmetry, what do? Well, we take the two intercepts, so negative 2 over 5, and we add them up, and 8 over 3. Right? We add up the x-intercepts. You could also do it the other way, 8 over 3 plus negative 2 over 5, which would be 8 over 3 minus 2 over 5. You're going to get the same value. And then after we add them up, we have to divide by 2. Just don't forget this 2 over here. It's easier to remember when you're dealing with integers here, right? You're adding up integers, then we divide by 2. But when you're adding up fractions, because you already have the fractions there, you might forget to put the bigger fraction of dividing by 2. So just don't forget that right there. Now, the negative 2 over 5 plus 8 over 3, let's actually do that on the side over here, just to not get too messy with the main work. So we need a common denominator here, which would be 15. That would be the lowest common denominator. So multiply this by 3, multiply this by 3, multiply this by 5, multiply that by 5. So we'd end up with negative 6 over 15 plus 40 over 15. Okay, so that's going to give us what? Negative 6 plus 40 would give us 34. And then that's going to be over 15, like that. So this 34 over 15 ends up being the numerator here. So we'd end up with 34 over 15 divided by 2, which is like dividing by 2 over 1. So we could rewrite this as 34 over 15 divided by 1, or divided by 2 over 1, which is like 34 over 15 times 1 over 2. Right? Just be careful with your fractions here. Another thing you could do is, instead of dividing this whole thing by 2, you could take this and just multiply it by 1 over 2, and then just work with this bracket first and then multiply by 1 over 2. So you'd end up getting to this point a little bit quicker. Just whichever way you do it, just be very careful with your algebra here. And that's why keeping track of these decimals is helpful, because you could check your answers along the way fairly quickly. So what we'd end up with here, 34 times 1 gives us 34, 15 times 2 would give us 30, and then we could divide both the numerator and denominator by 2, so we'd get 17 over 15, like that. So that right there ends up being the axis of symmetry. So the vertex would have an x value of 17 over 15. And as I mentioned, I think it's good if we keep track of the decimals. So 17 over 15, that would end up giving us approximately 1.13 in decimals. And then notice you could check this with these decimals here. So actually, because we are, you know what, we're getting a little bit more specific here, a little bit more detail with these decimals. So I'm going to actually round this to 2.67 to 2 decimal places, because if we just do 0.7, then there's like a 0.3 difference, or a 0.03 difference over here, and that's going to affect our check. Our check is not going to be as precise, right? Because if we took 2.7, subtract 0.4 and divided by 2, right? So we're playing with these just to see what the axis symmetry is going to be in decimals. We'd end up with 2.3 over 2, which would give us 1.15. And notice that this and this are different, versus if we have 2.67 over here, we'd end up with 2.27 over here, and then that divided by 2 would give us 1.135. And so notice that this here, it's closer to this. It's not exact because we're rounding over here, but it's close enough where we could be fairly confident that the fraction that we got is correct. So it depends on the kinds of decimals that you are using. It might be better to round a few decimal places to make sure that your checks on the way are correct. Or if you're, if you're even really confident with your fractions, with your algebra, maybe you don't even have to get these on the way, right? You could just work with the fractions. Just be, again, very careful with the details. Now, to get the y value of the vertex, what we would do is we would plug in this x value for the x values in the equation. So I feel like this, again, it's going to be a little bit detailed. Just be careful with your algebra over here. Like that. So we got to multiply, we got to work with these two brackets first. So we would multiply these. So notice 5 goes into 15 3 times here. So we'd end up with 17 over 3 plus 2. It's like 2 over 1. So this would end up being 6 over 3. Like that. And then over here, 3 goes into 15 5 times. So we'd end up with 17 over 5 minus 8 over 1, 5, 5, so that'd be like 40 over 5, like that. So we'd end up with negative 2, 23 over 3 times 17 minus 40 would give us negative 23, and then that's going to be over 5 over here. Okay, so again, if you want to take a little bit more steps to do this, no problem, just make sure that you're getting the same values over here. And now we just have to multiply the numerators and the denominator. So what would happen here? Negative 2 times 23 times negative 23, that would give us positive 1058. And then 1 times 3 times 5 would give us 50, like that. Right, so we end up getting 1058 over 15. Like that. And then the decimal of this is approximately 70.5, like that. Okay, again, keeping track of the decimals is going to help with the graphing because it's kind of tougher to see what these numbers here are going to be. Right, so this ends up being the vertex, and then let's get the y-intercept as well. Because it's an easy calculation. So the y-intercept, all we have to do is plug in 0 for everything. So we'd end up with negative 2 times, this goes to 0, 5 times 0, 0, plus 2 would give us 2. 3 times 0, 0, minus 8 would give us negative 8. So we'd end up with what? Positive 32. Like that. So the y-intercept ends up being 0 and positive 32. Let me just make sure. Yeah, looks all good to me. And now we have enough information, I feel like, to make the graph. So let's figure out what to go up by here. So with the x values, let's go up by 0.5. So we'll have 0.5, 1, 1.5, 2, 2.5, and 3. So we'll have 0.5, 1, 1.5, 2, 2.5, and then 3. So over here we'll have negative 0.5, and then we'll have negative 1. And I think we're all good there for the x values because this x-intercept is only going to negative 0.4. And then the y values, let's go up by, we're going up to 70, so let's go up by 10. So we'll go 10, 20, 30, 40, 50. Actually, you know what? Let's go up by 20. So 20, 40, 60, 80. Not as detailed, but enough to make a fairly detailed graph. If you want to zoom in a little bit more and use more scale over here, whether on the x-axis or y-axis, when you're making your graph, feel free to do so. So let's start off with the x-intercepts. We got negative 0.4, which would be like over here. And then we got 2.67 or 8 over 3, which would be about, let's say over here. So let's label these. We got negative 2 over 5 and 0. I'm going to label the fractions over here. And then we got 8 over 3 and 0. For the x-intercepts, the y-intercept 0.32, that's going to be like over here approximately. And then we have the vertex at 1.13, which let's say is like right there, and then 70.5, which would be approximately like right there, like that. So this vertex here is 17 over 15, 1058 over 15, like that. Okay, and now notice we can match everything, and notice it makes sense that the y-intercept's here because this is the vertex, has to go through that intercept, has to go through this intercept, so at some point it's got to go through the y-axis approximately in that area. So it does make sense that we are getting a y-intercept of positive 32, like that. And notice it opens down, we have a negative a value, so that also makes sense. All right, so fairly tedious. Again, same process, but lots of algebra. But if you do end up getting something like this and you want to make a fairly detailed graph, or your teacher requires you to go into that much detail with the fractions, this is the process you want to take. And then finally, part C, we got y equals negative 3 times x plus 1 over 3 times x minus 11 over 6. So this one's a little bit unique because notice the x values are by themselves, but then we have fractions here. But it's the same as when we had, like, let's say x, let's put other numbers here, like x plus 5 times x minus 2. From here, we could tell the x-intercept is negative 5 and positive 2. Well, same thing. There's nothing to divide here, so we could tell the x-intercept here is going to be negative 1 over 3, and over here, it's going to be 11 over 6. Okay, but if you do want to show it algebraically, what would you do? You'd plug in 0 for y, negative 3x plus 1 over 3, x minus 11 over 6, like that. And then we have to find out when does x plus 1 over 3 equal 0, when does x minus 11 over 6 equal 0? Well, that's going to happen when x is negative 1 over 3 and when x is 11 over 6, right there. Right, so when the x values are by themselves, a lot easier of a calculation. You could just look at it and see it. Just remember to switch the signs, as we mentioned many times in previous videos. The tougher ones are when there's something in front of the x. Then you got to actually algebraically do it to get the values. But actually with time, if you get enough of those kinds of questions, then even if there's a number in front here, you'll start getting these values just quicker in your mind. You'll know to just basically switch the signs. Basically going to be that number divided by whatever is in front there. Okay, but initially I recommend doing this algebra over here. And your teacher may require you to show it like this, no matter what kind of factors you're dealing with. So let's keep track of these x-intercepts. So we got negative 1 over 3 and 0. And then we got 11 over 6 and 0, like that. And then let's also keep track of the decimals. So this would be negative 0.33 and 0. 11 over 6, that would be approximately 1.83 and 0, like that. Now from here, let's get the axis. So the axis is going to be the sum of the x-intercepts divided by 2. So -1/3 plus 11/6. That's going to be divided by 2. So let's do this on the side. This by 2, this by 2. So we'd end up with -2/6 plus 11/6, which would give us 9/6. Divide by 3, divide by 3, which would be 3/2, like that. So that's just this part, the numerator. So 3/2 divided by 2/1, which is like 3/2, divided by 2/1, which is like 3/2, times 1/2, which would give us 3/4, like that. So 3/4 ends up being the axis of symmetry, or the x value of the vertex. Now, keeping track of the decimals, that's 0.75. And notice that if we check with the decimals, -0.33 plus 1.83, that would be 1.5, divided by 2 would give us 0.75. Okay, so checking the answers with the decimals does pan out. So we could be pretty confident that we're all good so far. Now the vertex, what we got to do is take this 3/4 and then plug it in here to get the y value of the vertex. So we'll have 3/4 plus 1/3. Just trying to be super careful here with everything I'm doing. Yeah, it looks all good. So let's work with both of these brackets on the side here, just to not make things a little too messy. So 12, common denominator. So we'd end up with 9/12 plus 4/12, which would give us 13/12. So we'll have -3, that's like over 1, times 13/12. And then we'll have 3/4 minus 11/6. 12 again, common denominator, 3, 3, 2, 2. So we'd end up with 9/12 minus 22/12, which would give us -13/12, like that. Right? So this ends up being -13/12. And then from here, what we can do is multiply all of the numerators. So -3 times 13 times -13 would give us positive 507. And then 1 times 12 would give us 144, like that. And then we could actually simplify this. We could divide this by 3, divide this by 3. So we'd end up with 169/48, like that. You can also take this 3, put it into this 12 4 times. -1 times 13 times -13 would give you positive 169. 4 times 12 would give you 48, like that. Right? So whichever way you do it, 169/48 ends up being the y value of the vertex. And then this decimal here, it's approximately 3.52, like that. All right, and then let's, even though it's not required, actually it's going to be, in this case, the y-intercept is going to be a little bit more it's going to be a more cumbersome calculation because we have these fractions here. They're not numbers, but it's still all good. So plug in 0 for x, so we'll have 1/3, -11/6. After plugging in 0 for x, we're getting the y-intercept. So this cancels out, so we end up with just -1 times -11/6, which would give us positive 11/6. So the y-intercept would be 0 and 11/6, which is 0 and 1.83, approximately, if we're keeping track of the decimals. And then from here, I feel like we can make a graph now. So at this point, let's see what we're working with. So let's go up by, let's go up by 0.4. So we'll have 0.4, 0.8, 1.2, 1.6, and then 2, and then we'll have negative 0.4, negative 0.8, like that. Again, you can use whatever scales you want, whichever way you want to zoom in. Then we got the y values of 3.5 and 1.8. So I'm going to go up by, let's just go up by ones. So we'll have 1, 2, 3, 4, like that. So let's plot all of these. So negative 0.33 and 0, that's going to be like over here. So that's going to be negative 1 over 3 and 0. And then we'll have 1.83, which would be like right here approximately. So that's going to be 11 over 6 and 0. Then we'll have 0.75, 3.52. So 0.75, that's like over here. 3.52, that's going to be like up here. So that's the vertex. So the vertex is, let's put the decimal, so 3 over 4, and then 169 over 48. And then let's put the y-intercept as well. Let's see if everything makes sense. So we got 0, 1.83, which would be approximately here. And notice that that does make sense because we have to go from the vertex through this intercept and through that intercept. So we're going to pass that y-intercept on the way it does make sense. It's going to be somewhere around there. Notice this graph is also going to open down, which also makes sense because we have a negative a value. All right, so connecting everything, we end up with that, and then we end up with that, like that. All right, so pretty intense video with the algebra. Once you get these kind of different sort of factors where you got to deal with fractions, it really does add another level, especially if your teacher is requiring fractions. If they just require you to work with decimals, then it's a little bit easier. Then the work is probably cut in half. This video could have been probably cut in half if that's the case, but lots of teachers do require this work with fractions, hence I wanted to go over it. Right, so with these kinds of questions, just be very careful with the algebra, get your X intercepts, your vertex, and then I recommend getting that Y-intercept as well, just to make sure everything is making sense.